Our emissions of carbon dioxide are causing our climate to change. And too much CO2 in the atmosphere will also alter the very chemistry of our oceans. When carbon dioxide dissolves into seawater, it forms an acid. Just a small rise in the acidity of seawater, combined with climate change, may leave coral reefs, the most biodiverse habitats in the ocean, struggling to survive. But that's just touching the surface. By the end of the century, acidification could leave some types of plankton unable to form their shells. And plankton is at the foundation of nearly all marine ecosystems. If key species of these tiny organisms are lost, everything else that depends on them for food could also start to disappear. Carbon dioxide pollution threatens to change life in our oceans out of all recognition within the span of a single human lifetime.
In Antarctica, few animals can survive the howling winds and frigid temperatures up on the land blanketed by snow. But here in the Southern Ocean, under the serene, cool blue ice cover, Antarctica is teeming with life. In these frigid waters live creatures that would feel right at home in a 1950s monster movie. Giant sea spiders, jellyfish, anemones, and sea urchins.
They're living in water that's so cold that you can't even put your hand in it for 5 seconds without feeling extraordinary pain. It's just like right above the freezing point of seawater. It's so cold.
Today, the ability of these animals to survive in sub-freezing waters is being tested by a new threat, ocean acidification. What's making the oceans more acidic? Scientists blame the carbon dioxide created by the burning of fossil fuels. The CO2 goes into the atmosphere, but as much as 30% is then absorbed by the oceans. The more carbon dioxide, the higher the acidity. In the last 150 years, as CO2 has increased in the atmosphere, the pH of ocean surface waters has dropped by around 0.1 pH unit. That's a 26% increase in ocean acidity. And the Intergovernmental Panel on Climate Change predicts an additional drop of 0.2 to 0.3 pH units by the end of the century. That's a 100 to 150% increase in ocean acidity since before the Industrial Revolution. As the ocean becomes more acidic, it makes it harder for marine animals that build their shells out of calcium carbonate, like corals and oysters. At the University of California, Santa Barbara, scientists are studying the effects of higher CO2 on sea urchins.
We mix the carbon dioxide into our seawater tanks to mimic future high CO2 oceans, levels that we thought we'd go to in 100 years or something. And we do start to see effects at those high numbers in terms of slowing down their growth. They are a little bit smaller at any time in development. And also there's some effects on fertilization, we think, when water gets really acidic.
Two recent events clearly show that ocean acidification has already arrived on western shores and could have a direct impact on the seafood we eat. In 2007, Science magazine reported that surface water in places along the California coast was already more acidic than researchers predicted. Around the same time, news reports started trickling in from oyster hatcheries in Oregon and Washington state. Millions of larvae were dying. The culprit, ocean acidification. Since the beginning of planet Earth, animals have adapted to changing conditions. But adaptation can take thousands, even hundreds of thousands of years. Now, with millions of tons of carbon dioxide going into the oceans every day, can the creatures of the sea change quickly enough to survive in the changing oceans?